everyone. Today we are going to learn the principles and the structural characteristics of solar thermal power generation, including the principles and the system structure of solar thermal power generation. The principle of solar thermal power generation is to use solar energy as the heat source and use a concentrator to gather the solar energy, heat the working fluid, generate the superheated steam through a heat exchanger to drive the turbine and drive the generator to generate electricity. The steam from the turbine condenses through the condenser and is pumped back by a water pump for recycling. The diagram shows the schematic diagram of the solar thermal power generation system, with the concentrated heat collection subsystem on the left, the heat storage subsystem in the middle, and the thermal power conversion subsystem on the right. During the day, the solar energy collection subsystem absorbs the solar energy and converts it into the thermal energy. A portion of the thermal energy is sent to the thermal power conversion subsystem for power generation and then sent to the power grid. The other portion of the thermal energy is stored in the thermal energy storage subsystem and released at night to supply the thermal power conversion subsystem for power generation. The solar thermal power generation system consists of a solar energy collection system, a heat transfer system, a thermal energy storage subsystem, and a turbine generator electronic system. The solar energy collection subsystem includes a concentrator, a receiver, and a tracking device. A concentrator is a device that collects sunlight and concentrates it, raising the temperature of the heated working fluid. The receiver converts the solar radiation energy into the thermal energy and transfers it to the working fluid. The function of the tracking device is to ensure that the solar radiation can be reflected onto the receiver through the reflective mirror. The heat transfer system transfers the heat energy collected by the collector to the heat storage system. It requires small heat loss in the heat transfer pipeline, low pump power for conveying heat transfer media, and the low cost of heat transfer. The heat storage system is located between the collector and the steam turbine generator unit to ensure the stable operation of the unit. If the grid load exceeds the generation capacity of the power plant, it will cause a decrease in the frequency and voltage of the power grid, and in severe cases, it will cause the entire power grid to collapse. Therefore, the solar thermal power generation system must have a heat storage subsystem. The steam turbine generator system generates the superheated steam through the heat exchanger, which drives the steam turbine to generate power and drives the power device of the generator to generate electricity. There are two main types of solar thermal power generation systems, focused and non-focused. Among them, focused systems mainly include true, tower, and disk types, while non-focused systems are not very common. The following is the mechanism of a slot solar power generation system, which uses a 12 parabolic reflector to concentrate light and heat the carrier medium in a single dispersed solar focused collector. It is heated into steam and then collected into a steam turbine, which generates power to drive the generator to generate electricity. The structure of the 12 solar thermal power system consists of 4 subsystems. 1. The concentrating solar collector includes a focusing mirror, a receiver, and a tracking device. 2. The auxiliary energy device includes a heat transfer pipeline and a heat exchanger. 3. The heat storage device includes a high-temperature storage tank and a low-temperature storage tank. 4. The turbine power generation device. The concentrating solar collector includes a spotlight reflector, a receiver, and a tracking device. The concentrator uses a flat mirror to reflect sunlight onto a parabolic mirror, and the parabolic trough mirror focuses the incident sunlight onto a line at the focal point. On this line, the receiver's collector tube is installed, and there is an absorber tube inside the collector tube to absorb sunlight and heat the internal heat transfer liquid. The tracking method of the parabolic trough collector can be arranged in the east-west axis, with only regular adjustment of the elevation angle. The mechanism is simple, but the efficiency is low, and it can also be arranged in the north-south axis. Single-axis tracking of sunlight requires an automatic tracking system. The parabolic trough collector heats the heat transfer liquid to around 400 centigrade, and the heat transfer liquid heats the water through the heat exchanger into steam at around 300 degrees Celsius, which is used to drive the rotation of the steam turbine and generate electricity from the generator to ensure the stable operation of the system. In the system, there should be heat storage devices, generally including high temperature and low temperature heat storage tanks. The superheated steam output from the heat exchanger is injected into the steam turbine for power generation. The water discharged from the steam turbine is converted into water through the condenser and then sent to the superheat exchanger by the feed water pump for repeated circulation. The electricity generated by the generator is converted into high-voltage electricity through a transformer and transmitted to the power grid.